so we can go live now. And we are live from California and Italy simultaneously. Welcome everybody to Data on Kubernetes Community live stream number 141. I don't know how to say it in Italian, but I will learn that very quickly from our guests. Before we get started, as usual, thank you so much for joining us. Super stoked about what we're going to be doing today. Just actually wrapped up a Twitter Spaces talking about the whole expansion of the Data on Kubernetes landscape, the different technologies that we're seeing. After all, we've been around for 2 years now, celebrating our second birthday. It's really good to see the growth of the community. As you can see, 141 live streams in less than 2 years, working on our DoK Day, the next one coming up in October. Going to drop the link here, and I hope today's speakers will also submit a CFP. We're getting CFPs already for DoK Day in Detroit, which will be hybrid. So we'll have about 150, 200 people with us in person in Detroit, and then the rest of our audience online. And please get those CFPs in there. Like I said, we started out this community 2 years ago with a database and storage focus. Since then, we've seen other use cases, different kind of workloads making their way in. One of the most exciting spaces, which is why we dedicated extra time to this today earlier, is this aspect of data science, ML, AI, all these different workloads that are making their way in. So today I'm joined by two wonderful individuals that are in the amazing country of Italy on the other side of the world, 9 hours ahead, living in the future. Dario and Iacoppo, welcome. Dario, since we got your screen on, your camera on, Iacoppo will explain why he's a little bit camera shy today later. But Dario, who are you and how'd you get into this space in the first place?
And thanks all, because a really nice introduction. So my name is Dario. I am from Italy, from the north. And, you know, I'm a software developer because I love to write code, especially on Kubernetes, because I've been a site reliability engineer. So I started writing operators, controllers, custom controllers, and so on and so forth. So I'm here with Iacoppo because there is a nice story, because Iacoppo is also the son of one of my teachers in high school, and we are doing the same job, although he's working in university and instead I'm working in the private sector. But I'm not doing data, but I'm writing operators for Kubernetes, and I'm here presenting CAPSULE, that is the multi-tenant operator for Kubernetes developed by CLASTIX and by the open source. So really happy to be here.
Good stuff. And interesting backstory. Nice to see those sort of connections coming through. We don't need to get too much into regional differences, but we do have some other community members that are in Italy. Most prominently, shout out to Gabriele Bartolini, who's in Prato. Is there a rivalry at all between Turin and Prato? Or
well, no, absolutely. But, you know, it's different regions. So in Prato, well, in Tuscany, everybody eats pizza. So luckily he's not living in Pisa. So okay. That's good.
Okay. So those are things that unify you. That's good to know.
Yeah, everybody. Yeah.
But this is what's cool. And I really encourage folks, whether it's in our community or any other community, be in these spaces where you have people from all over the world, really take advantage of that and try to learn about other cultures. There's tons of stuff that you can learn there. So anyway, shout out to all the folks in Italy. Iacoppo, you are a little bit camera shy today. You can explain that if you want, but tell us about your background. You're sort of on the academic side. How'd you get into this world? What kind of motivates you to be here today?
Hello, thank you for the introduction. So, as you said, I work in university. I'm post-doctoral researcher. I always did research on high-performance computing and cloud computing, and also on workflows, which I see as a way to make them work together, but at the same time keeping them separated, doing each one what it can do better. And unfortunately, today I will not show my face because I just got the coronavirus, so I ensure that you don't want to see my face today. It's not a good thing to see. But coming to the explaining why I started working on Kubernetes is because I am also one of the maintainers of our research cloud in University of Torino, which has been built directly between the offices. So when you enter in the department, you see the data center, and the aim is to make students aware that cloud is not something that is in the sky, but exists concretely somewhere, basically.
All right, good stuff. That being said, folks, if you got questions, please feel free to put them in the YouTube chat. If not, you can definitely continue the conversation later on in Slack. If you want to start sharing your screen, go for it.
Thank you. I'll try again. So,
and folks, get ready to see the coolest profile picture you've ever seen in your lives. Hope you're ready. Look at that. All right. So when Iacoppo isn't doing postdoctoral work, doing research, he is modeling, doing underground work as an actor. I am convinced he was an extra in Game of Thrones or some kind of awesome TV series. I can't, we got to get a hold of the photographer. We got to start doing events in Italy. I want this photographer to make me look at least half as good as you, and I'd be very happy about that. So anyway, that being said, I'll let you guys take it away. Go for it.
Thank you very much. I just play a guitar in a metal band, so this is the explanation. So today...
well, sorry. Now that you said that, no, that's conversation take a totally different direction. What's the name of your band so we can take a look at it? Maybe you can put a link in the chat here in Zoom, and I can share that.
Yes, I will do it. Its name is Godless Entropia.
All right, Godless Entropy. My Italian is just flying by leaps and bounds. That's good. Godless Entropy. That sounds good. And you do have a science background, so entropy is something you're probably well familiar with. Anyway, that's cool. So that's good. We always like to mix these things, though. You know, we do hip hop, we do music, we do art. So getting some metal in there is also good. Love me some good metal. Anyway, go for it.
Thank you. So today I will talk about this platform for data analytics as a service, which we developed at the University of Torino and in cooperation also with CLASTIX for the multi-tenancy part. And in particular, it is called Dossier. And we will arrive step by step to Dossier, because Dossier is an ensemble of multiple things. But we will start from a very simple sorry for the voice. A very simple thanks to all companies and organizations that make this talk possible, which are CLASTIX and University of Torino, the Data on Kubernetes community, which we already know what they are, plus 2 European projects, the PELT project and the DAaaS project, which are the context in which this research has been developed and will be maintained, basically. So why we need to offer data analytics as a service? Well, because in the 99% of the cases, people doing data science are not the people that provide services. And even worse, people that do data scientists do not understand almost nothing of how to build up a cloud or a Kubernetes cluster, and vice versa. People in the involved in the complex IT and distributed systems in the cloud often do not know how to train a transformer or stuff like that. So this is necessary to let data scientists be able to focus on data science and not on building up their own environment. And in fact, the major cloud providers are all offering data analytics as a service solution in their private clouds. So, but if you want to start your data analytics as a service platform, what you have to do, what you have to care about? Well, there are several aspects that we will analyze then in the context of Kubernetes, but let us introduce them in a general way. So, if you have data and your data are sensitive, for example, medical data or bank accounts data, you want to be sure that data remain private and that they are protected both from malicious users and in some cases also from the provider itself. And this is done with 2 mechanisms. The first is data encryption or secure transport of the data, like using HTTPS or secure protocols. And the other is multi-tenancy, so segregation of accesses to resources, storage, memory, and everything that can be used to exploit the system to access the data. But then you also have to ensure performances and scalability, which is like at the other side of the world with respect of security. Because if you have to train a neural network, you want to train it fast, because neural networks are huge models and require a vast amount of computing power. And so you cannot train them, for example, without high-end GPUs, because otherwise it will take ages. Also, for the discussion I had before, you must provide user-friendly interfaces and faster prototyping tools to domain experts, because you cannot ask a data scientist to install a Kubernetes where to run Kubeflow with TensorFlow, or you cannot ask him to go to an HPC center and compile PyTorch on a Power 9 processor from scratch, because it is not his job, and it will take ages to do that just to prototype a simple experiment. And finally, you have to ensure portability and reproducibility of data science experiments, because data science is, in many cases, quite delicate, because changes in the data pre-processing pipeline or in the hyperparameters of the model can have a huge impact on the final result. And so you want to avoid at all costs to add additional sources of variability in the experiment. So you want to run in a portable and reproducible environment, so that if you validate your prototype and you bring it to production, you can expect more or less the same results. These are all crucial aspects when providing this kind of platforms. And
what? Sorry, one thing real quick though about that. Just can you go back to that slide?
Yes.
So the thing is, I'm originally from the United States, but I've been living in Europe for the past 12 years actually. 1 year in the UK, pre-Brexit, and then now 11 years in Spain. When we talk about privacy and protection, it's a market. The cloud market is very much monopolized by the United States and China. Do you expect that there will be in the coming years a European-backed and possibly EU-backed public cloud?
So in research, we are trying to do that, but it is very difficult, because we are terribly late. We are terribly late with respect to United States, and also we don't have at the moment companies with enough strength to push for so large investments. If you think now we are trying to produce our own processor, our own CPU in the European Processor Initiative, while USA, China, and other parts of the world are trying to build quantum machines. So we start very late, but it is undoubted that the push of GDPR and privacy-preserving norms are driving many small companies to provide their own clouds. What I see is that we will have probably in the future many small clouds in Europe, provided by either scientific and research infrastructures or small companies, to run only those workloads that cannot be run on US for example, for limitations like the Cloud Act or stuff like that. But we will never have a real competition at scale, basically. This is my view.
Fair enough. No, makes sense. Anyway, just want to touch on that real quick, considering where we're all at in different parts of the world and different things that are going on. Anyway, continue.
Thank you for the question, because it's one of the things we are debating like daily in the research group. So thank you. So when you have to provide all these requirements to your platform, why you should choose Kubernetes? Well, for portability and reproducibility, it is obviously a great choice, because you run on Kubernetes, then you can put Kubernetes over any cloud provider and you're okay. And more or less, Kubernetes is always the same, with the exception of data storage. But this is a sad part of the story. But many aspects, it is quite always the same. So it is portable and is reproducible. It is also widely used. So if you need already developed framework, PyTorch, TensorFlow, anything, probably there is a Kubernetes Helm chart to deploy it, or an operator, or at least a Docker container that can used to run it on Kubernetes. It is reliable because it has been tested worldwide with huge workloads. So the control plane, at least it should be reliable. And it is also extensible. So if something is missing, you can try to define your abstractions. It is quite easy to define new abstractions in Kubernetes. It is difficult to program the right abstractions, those that you need. But in principle, writing an abstraction in Kubernetes is quite easy to the custom resource definitions, for example, or the operator pattern. But so why we cannot stick with Kubernetes and we need something else also? Because Kubernetes alone is not multi-tenant. Otherwise, Dario would never have opened his company. No, I'm joking. But it is true that in Kubernetes alone, it is very difficult and not centralized to provide multi-tenancy in a cluster. It is not transparent because there are many layers of software-defined networks and also software-defined storage that can hinder performances, especially in HPC workloads. GPUs are not a problem. They are more or less always mounted as pass-through, but network and storage are a problem when you scale. And also, it is not user-friendly, because if you pretend that a data scientist that is using his Python script starts learning all the different Kubernetes APIs, names, and how to concatenate them, it will insult you probably. So we agree that we can use Kubernetes, but we need something else. Which is this else? Well, our solution is to use Jupyter Notebooks. Jupyter Notebooks are already widely used by data scientists because they basically give you fast prototyping. You write your program, you execute it interactively, see the result as soon as it is produced. Then you can execute cells in the order you want. You can go back, insert a new variable, review your data pipeline, and you can also document what you're doing so that another data scientist can come and reproduce your experiment or help you in boosting your results. But they cannot scale. Jupyter Notebooks native do not scale because the execution model is sequential. You execute one cell after the other from beginning to the end or in a different order, but always one active cell at a time. Communication protocol is based on 0MQ, so it requires bidirectional connection from the server, which is the web interface, and the kernel, which is the program that computes, the process that computes the Python scripts inside the cell. And normally they are on the same machine, but they can also live in different places. But for example, you cannot place the kernel on an HPC worker node, for example, because HPC worker node have no outbound internet connection. So if you place the kernel on a HPC worker node, it cannot communicate to the server. So connection is lost and the protocol doesn't work. And there is Jupyter Hub that supports multi-tenancy, but is a limited support because you have one user, one server. So one user, one notebook, basically. Not groups of users with given resources that can share notebooks. This is not support. So it's a weak multi-tenancy. And so we extended these Jupyter Notebooks with what? Well, first problem is that they do not scale. So we want them to scale, but not also to scale inside the Kubernetes cluster, because we said Kubernetes alone is not enough. We want to span cells everywhere, on one cell on an HPC to do neural network training, another cell on a quantum machine because we need quantum advantage for this particular simulation. Then we want to put another cell on an FPGA because we want to test energy efficiency, and then we want to come back to the cloud because we want to see the charts of our results and comment them. And so this is what hybrid workflow have been written to do. So what are hybrid workflows? Hybrid workflows are workflows, so steps and dependencies between steps that can span multiple heterogeneous and independent computing infrastructures. What does this mean? It means that a single workflow, for example, with 2 steps, can run 1 step on the cloud and 1 step on HPC. And this also means that things are heterogeneous because cloud is very different from HPC. And also independent, because if I run on the cloud doesn't know the existence of my HPC facility, and vice versa, HPC facility doesn't know the existence of my cloud. So probably they will not have a single shared data space in which I can put the data to read and write them from both locations. In the Cross project, we are trying to build these workflow models to foster the convergence of HPC, big data, and artificial intelligence on clusters and cloud. And this is basically the formal model behind this approach. This is formalized. I will not annoy you with formal Greek letters and stuff like that.
Oh, please do. Come on, do it.
No, I didn't put on the slides, and I'm not in a good shape to do that. But if I'm
for another day.
Yes, another day. For sure, second part. But we are publishing now the formalization of this. So as soon as it will be published, I will maybe put the link on the Slack if someone want to kill himself with Greek letters. But basically, and from a high perspective, a hybrid workflow model is a workflow, so a graph, in which you have different steps that are interconnected with dependencies, and each step can be mapped to a different location in charge of its execution. And locations are interconnected in a topology. So basically, like this one, you have 3 steps. Steps communicate through data that are ports in this case. So step 1 produces 3 data. The first is received by step 2. The other 2 are received by step 3. And the step 2 is mapped on a quantum machine. Step 3 is mapped on an HPC cluster, and S1 is mapped on 3 different cloud VMs, with the gray one acting as the control plane of the whole execution. And locations, which are the lower part, are interconnected by communication channels, because not all locations can communicate directly to all the others. For example, HPC cluster cannot exit, can only receive inbound connection, but cannot go outside because it has not outbound internet connection, as I said before. And quantum machine, the same, is used as with the accelerator pattern. So you submit, you get the result, but you cannot move that. So what we want to do, take Jupyter Notebooks, take hybrid workflows, put them together. How? You take a notebook and treat it like a workflow, in which each cell is a step. So S1, S2, S3 are cell 1, cell 2, and cell 3 of our notebook. And in the notebook metadata, specify all the rest. So you specify the dependencies between the steps, the locations in which you want to offload the execution of that cell, and all the topology of the involved locations, so that you can figure out how to transfer data from one location to the others. And the important thing is that this notebook is a way to put host language, which is Python code, inside the cells, and coordination language, so description of the dependencies, the execution strategy, the data movements, in the same document, but keeping them well separated. And this is basically the advantage of this approach with respect to, for example, having 2 totally different files, the program and in another place the workload definition, because this can be, how can I say, can make you lose some pieces, but also you cannot have to modify. You don't have to modify the Python code to insert your specification of the distributed strategy, like you do, for example, in parcel array, DAaaS, that was mentioned earlier today in the previous talk. Basically, it is true that you only put an annotation on the Python, so it's not a huge modification, but still you stick with a given library. While when you rely on metadata, which are declarative, any implementation of the Jupyter engine that can interpret that metadata can be used, and multiple implementation can be switched one to the other, and you can also extend an implementation with your engine if you feel that something is missing, without changing neither the code nor the metadata. This is, in my opinion, the good part of the approach, but I wrote it, so I'm not, how can I say? I am on my part, basically. So I will accept criticism from people that listen very carefully, because they are very important to make it better, basically. So this is basically the architecture. As you can see, there is the user that interacts with the notebook, so the classical file with a cell plus the metadata, which specify the workflow. Then we augmented the front end of the Jupyter server to pass the metadata to the kernel, and in the kernel, we interpret the metadata, automatically resolve dependencies between cells. So if a cell reference a variable that is declared in the previous cell, it is automatically marked as an input dependency. And we use Streamflow, which is a workflow management system to offload the computation to remote locations. Kubernetes, HPC, SSH-based VMs, Docker, all these things. Cloud Pickle is used to serialize and deserialize. Serialization and deserialization is the crucial part of this approach, because you basically have to remotely execute a piece of code, so you have to serialize and deserialize anything in both directions. Otherwise, nothing can work. The drawback is that this is only made for Python at the moment, so it's not code agnostic. Metadata can be the same for any language, but we implemented the kernel only for Python to have a proof of concept. But same metadata can be used also for other languages. Now, I prepared these slides that I would like to substitute with a demo. So it is a risky time. Can I try to demonstrate?
Yes, you can, but I want to know before we start, as the lead guitarist, or what instrument do you play?
I play a drop 1-tone 7-string guitar. So it's like a bass.
Yeah, I wouldn't expect anything less. But that being said, you're about to do a demo, and you're in a band called Godless Entropia.
Yes.
Which demo gods do you pray to?
Let's hope.
We mentioned the Greek. We mentioned the Greek alphabet. We can use the Greek gods today. That's okay. Anyway, go take it away, man. Go for it.
Thank you. So now I'm accessing, but this I will explain you later. Basically, I will come back on these screens. So now basically I'm just deploying a Jupyter notebook as all the others. This is spawning directly on the same Kubernetes cluster of the Jupyter Hub extended. Now you see Dossier, but imagine this as a Jupyter Hub, common Jupyter Hub. Now I want you to see how these workflows can be used. So this is basically a very simple a very simple notebook in which we have 3 cells. First cell declares an array of 5 variables and measure performances. The second cell iterates over all the variables in the var and writes a line and then sleeps for 5 seconds. And then we measure the total time. So if we execute this from the beginning to the end, we should take 5 times 5, so 25 seconds. But I just defined here a scatter pattern, which basically tells the engine to take the variable var, which is a list, and create an instance of the cell for each element of the list, and then process them concurrently if we have enough cores in parallel. So the theoretical time is 5 seconds because we process all of them in parallel. Also note that all the input dependencies here, print function, time, string here, and also var, have been automatically inferred by the engine. So now I run all, cell run all, and if it works, we should see a total time for completion of, you see, 5.85, which is not 5, but it is much lower than 25. So this is a first way of augmenting the notebooks with parallel patterns. Not that I did not change any line of code here. Another example, very short. This one, in this time we have 2 variables, A and B, and one cell that processes only A and one cell that processes only B. So we can process A and B in parallel because this cell does not depend on this other cell. And this is basically what our workflow does. If we execute it from the beginning to the end, we should take at least 10 seconds. If we run it with run workflow, which extracts the workflow structure and organize the concurrent execution, we only take 6 seconds, which is less than 10. Now, these are really silly examples, but this can be brought at scale. And for example, with the first thing, with the scatter thing, we trained 256 neural networks in parallel remotely on a HPC facility with the notebook running directly on my laptop. And with the second feature, the workflow construction, we ran a simulation on the DaVinci HPC facility, putting the notebook on the login node. And we basically took as the same time as a direct execution through PBS, which is the workload manager of that HPC facility, but using an interactive interface with Jupyter and without changing any line of code. So now, come to the interesting part, come to the data. We have Jupyter workflows, but where is data privacy here? So it is a problem because data volumes in Kubernetes can only be segregated at a namespace level because persistent volumes are a cluster resource, and the only way you can avoid another user to attach to a persistent volume is to put it busy on your namespace. So you take the volume. But if you use one dataset, one namespace, then, which is the only way for using multi-tenancy at the data level, then this means that with normal Kubernetes, you have to basically put all the tenant segregation at the namespace level. So you have to put accountability on the namespace level. You have to put resource allocation on the namespace level, network policy, and all the things configured per namespace. But with Jupyter Notebooks, one namespace, with Jupyter Hub, one namespace means one user. So basically, you should configure one tenant per each user. Why? Because you in Kubernetes cannot separate and you have only two levels, the entire cluster or the single namespace. And we, for this multi-tenant Jupyter workflow as a service, needed something in between, something that could separate the accountability from the access control. And we did it with CAPSULE that now Dario will explain much better than me.
Yeah, thanks a lot. Thanks a lot for the introduction, Iacoppo. I'm really happy to be here. And you described very well the problem because, as you told us, with Kubernetes, we just got two levels. So it means that we have to enhance the Kubernetes capabilities with the multi-tenancy. So I would like to start introducing the term of tenant, because tenant is just an abstraction. It's just a collection of namespace. And why we will need multi-tenant environments in Kubernetes? Well, I would say that because the flat hierarchy of namespaces in Kubernetes are not enough, especially in this case. So sometimes you need to take your applications, take your services to the next level and answer the multi-tenancy. How we solved this problem, this dilemma in the past, and the solution was to spawning multiple clusters. And that could be a problem, a cumbersome problem in the long term, because it means that you have to manage multiple clusters, and it means that you have to rotate the certificates, you have to take care of the alerts or the errors, the backup, the restore, and so on and so forth. So a lot of issues. Instead, if you could use a single cluster using the multi-tenant paradigm, you are saving a lot of effort from the operational burden. So what is CAPSULE? Essentially, it's an Apache 2 licensed operator. An operator in Kubernetes is a binary that is watching the API server and performing some actions on behalf of the human operator. And it's pretty simple to use because what you have to do, and Iacoppo, you can confirm that, and I'm pretty also happy to hear your feedback about that, but you just need to install using Helm or using single YAML manifest or using also the charmed Juju operator that we developed for the canonical distribution. And what's really cool regarding CAPSULE is that it's keeping the same user experience of dealing with Kubernetes. I mean, there are so many platforms out there that are providing multi-user management of a Kubernetes cluster. And sometimes you have to install a third-party plugin to your kubectl, or you have to use a third-party binary instead of kubectl. So it's really cumbersome, and developers they don't want to study a new application. They just want to stick to the official documentation of Kubernetes and having the same experience. And that's the reason why we try to design CAPSULE sticking to this simple solution. So it must be simple to use, and it must follow all the information and all the experience that an end user could expect using Kubernetes. So if you can pass to the next slide, Iacoppo. I think that we have also to try to understand how does it work multi-tenancy, because multi-tenancy means that we are going to have multiple users using the Kubernetes cluster. And it means that how can we identify a user? So it means that to use CAPSULE, it means that you have a Kubernetes cluster that is allowed to be used by multiple users. So these users are identified using an identity provider, and in the brief demo that you presented, Iacoppo, you are using Keycloak. So Keycloak, it's an OADC provider for Kubernetes, and it means that you're connecting somewhere and you're getting your users, your credentials. And then the Kubernetes API server is saying, okay, you're Iacoppo, you're Dario, you're Bart, so you can do this stuff. All the authorization part is managed in Kubernetes. So in the end, we just need to get a user, and from this user, all the user groups. So the first step is to identify a user, and then we are playing with the Kubernetes primitives, the Kubernetes controllers, like the dynamic admission controllers, and these are the validating and mutating webhooks, and along also with the resource owner reference. What is a resource owner reference? So the pretty that simple example is the pod that is belonging to a replica set that is belonging to a deployment. So it means that essentially there is a chain of ownership between the projects, well, between the primitives, between the objects. So it means that with the tenant abstraction, we're saying, okay, we got a set of namespaces owned by a tenant owner. So we are able to group them into this solution that is a Kubernetes cluster slice, I would say. I don't want to use the term virtual Kubernetes cluster because that wouldn't be fair. So it's a slice of your Kubernetes cluster where a set of rules are applied. So to the next slide, we can try also to understand why we should use a single cluster for multi-tenants instead of using multiple clusters. So I really love this representation because, as you can see here, besides the joke, because I do a lot of jokes, sorry for that, I'm Italian, and that's the reason. Anyway, if you have a lot of clusters, pretty sure that you're going to, how to say that? You are going to optimize the cost, because in the end you can have small clusters, and there is a downside because multiple clusters means that you have to perform multiple operations, but at the same time also having a huge cluster in that case could be cumbersome because it means that you're ending up with a single point of failure. So I'm not saying that CAPSULE is the silver bullet to solve all your problems. It really depends, but obviously it depends on what it depends. So it depends also on your organization, on your data. So we got customers and we got end users that are using CAPSULE spread across multiple regions. So they're using the GitOps approach in order to say, okay, we are reconciling all the operations, but we don't have a single point of failure. But they are taking the full advantage of the multi-tenancy. So in the next slide, we can also try to understand how are we identifying a user. So we all know that what we have to do is to issue kubectl, get namespaces, kubectl version, or whatever the command you would like to issue. But under the hoods, behind the curtains, there are so many involving components that sometimes we are getting lost about that. So keep in mind that when we are using a multi-tenant cluster, so with the authentication, so the authentication of a user, there is the client that is requesting to the identity provider a token. So I'm performing the login on the web page or using my authentication mechanism, and I'm getting this token, and then I'm using this token to authenticate against the API server, the Kubernetes one, that is configured to get a validation, so a verification of the token. And this is the result of the request payload. So it's not properly request payload because this is the JSON web token that we are getting from Kubernetes, well, that we are using against the Kubernetes. So with that said, we are able to identify a user. And why this is important? Because in the end, when you're dealing with multi-tenant, you're saying, I got multiple actors. I got Alice, I got Iacoppo, I got Dario, and each of them is belonging to a specific tenant. So it means that we have to identify them. And luckily, Kubernetes has been made with this feature from the beginning. Well, not from the beginning, but it has been introduced in the long term. But we are here, so we got it, so we are pretty happy. And in the next slide, instead, we are going to understand how it works. Because keep in mind that CAPSULE is intercepting all the requests by a user creating a namespace and performing some actions. So how are we doing that? It means that we are rebuilding Kubernetes API server? No, absolutely no. Kubernetes is really smart because it allows to mangle the requests that are sent to the API server. And this mangling is made of by webhooks, and it means that we are installing in the Kubernetes cluster two, well, not two, but more than two, but two kinds of webhooks, the validating and the mutating. So the validating, essentially, it's a sort of saying, okay, I'm checking this request, I can do this action, this user can do that, yes or no, so I can deny or approve the request. And instead with the mutating, we are able to say, I'm getting this request, I'm adding my own business logic, like adding the owner reference to the namespace. And in that case, adding the owner reference, it means that the namespace is going to be attached to the tenant. So if we try to understand how CAPSULE works, let's imagine I'm Iacoppo, I'm issuing kubectl create namespace. Since Iacoppo is part of the user group that is belonging to CAPSULE, there is a lookup in the tenant list. Keep in mind that tenants is a custom resource definition at cluster scope. So I'm just checking for the user and for the group in the list, and retrieving the tenant, I'm adding the owner reference to the namespace, referencing the tenant and the Iacoppo tenant. So far, so good, essentially. And please, next slide, Iacoppo. Why using CAPSULE? Because I'd say that CAPSULE is not a product. It's an operator, yeah, but I will consider it as a sort of framework, because so far CAPSULE was born during the pandemic, during the 2020. We were in our houses. I didn't know what to do, so I started developing this stuff along with Adriano, my business partner here in this adventure of the open source. And you know what? We discovered that a lot of people was using that for several reasons. We are really happy to be here with Iacoppo, because essentially they're using CAPSULE to build, I would say that, a machine learning platform, a deep learning platform based on Kubernetes, and decreasing all the toil of managing a fleet of Kubernetes clusters and enhancing their product. Although it's not a product, it's a platform, but you're getting the point, okay? So it means that with CAPSULE, you can, first of all, enhance the multi-tenancy of Kubernetes in a streamlined way. It means that you don't have to use a specific distribution. It's everything transparent to the Kubernetes API. So we are not introducing any custom resource definition for the tenant owner's perspective, just for the cluster administrator, obviously. And it means that if you would like to get rid of CAPSULE, you can do that. So it means that there are no vendor lock-ins. So you can use CAPSULE, you can take full advantage of it. And if you would like to uninstall it because you are tired of that, although it's pretty unfair because it's working well, I'd say, I don't know, Jacob, please provide the feedback. Anyway, you can do that. So it's pretty transparent. It's not invasive, I'd say. It's not opinionated. So it means that the multi-tenancy solution that you can put in place is totally shaped around your business. In this case, Iacoppo mentioned that you have to perform the network segregation between the tenants. And you can do that because we are supporting also the propagation of network policies. Or let's say I would like to limit also the resources used across the tenants. With CAPSULE, you can do that. And that's really cool because let's imagine, you know, I got my pods that are running in my namespace, and I would like to say, I cannot consume more than, I don't know, 10 GPUs, 100 GPUs, something like that. You can set this limit just at the namespace level, and you cannot do that at the tenant level. And keep in mind that the tenant level is a collection of namespaces. So instead with CAPSULE, since we are using tenant abstraction, you can set this limit to be considered across all the namespaces of the tenant. So it looks like a limit of a sort of virtual cluster, but in the end, you're using just a single cluster and you're happy about that. And also, what else? Obviously, it's everything based on YAML. So everybody loves YAML, I would say. I don't know. Sometimes I'm really tired of that, but we have to deal with that. So it means that you can define the tenant abstraction using the YAML language. You can use kubectl to get it explained, and it's pretty, I would say not pretty, but it's absolutely GitOps ready. It means that you can get your multi-tenant, well, your tenants declared in a Git repository, and these are going to be applied on every cluster where it is configured. So it means that there is a constant reconciliation, of all the rules that are going to be applied in the namespaces of the tenants, plus also the tenants deployed across all the clusters that you have configured. So, and I would say that this is in a nutshell what is CAPSULE is doing, and I think that we can talk also about what is Dossier. So next slide.
Yes, thank you. Another, if I can add, another good point of CAPSULE is that it works when you deploy it, which is not a typical thing of all the projects around the globe. And the other thing is that when you want it to do something, it does exactly that. And this is another feature that very important. By the way,
thanks a lot. I'm really happy to hear that.
It's the truth. By the way, to summing up all the things. So what is Dossier? Dossier is the big fusion of all we discussed up to now. So it is a multi-tenant distributed Jupyter as workflow as a service platform. What does it mean? It means that we use tenants to make basically accountability. I don't sell you 3 notebooks. I sell you 16 cores, 3 GPUs. 3 GPUs is very bad. 4 GPUs, and you can bring your data, spawn your notebooks, do your stuff, as long as in your tenant you do not go over your limit. So you can be 2 people, 20 people, 100 people, but you paid that amount of resources. You can use only that amount of resources contemporarily, no more than that. And this separates accountability, which is done at the tenant level, from segregation, which is done at the namespace level. Plus, we can move outside the Kubernetes cluster with Jupyter workflows. And since we have the topology of locations, we can monitor the information flow, which for sensitive data is important. So I know statically, when I see the workflow, where my data will be moved. And so I can also put constraints on that to avoid the data are moved in a particular location that I don't want. And so I can disable statically the execution of the workflow. Then we use Keycloak to associate users to tenants. So when you authenticate, you can be part of one or more tenants. So another thing, you as a user can have multiple notebooks running in different tenants if you are part of multiple tenants. And the last thing that remains is, what if I cannot bring my data on the Kubernetes cluster because GDPR, I cannot, my doctor doesn't want. So how can I do my computation in that case? Simply, I move the notebook from Kubernetes where the data reside. And this is the last thing I want to show you, if I can succeed to do 2 demos. So this is my user, my first screen. I see 2 tenants because my user is part of 2 tenants. I can select one of them. I select the first one. Then I can select 2 spawners. The Dossier spawner, which is the normal spawner I selected before. So spawn my notebook inside my Kubernetes cluster. Or per tenant configured external spawners that can be configured by system administrator to provide users of a certain tenant access to external resources, or also by users with the privilege to create spawner resources that can bring their own computing resources. And then if I select this one as my spawner, then this will spawn a notebook from my Kubernetes cluster to a remote VM on the cloud with a GPU, as you can see. And I wrote this script in Python that basically search for environment variable that start with cube, only to demonstrate that I'm not on Kubernetes. Didn't know how to demonstrate that I'm not running on Kubernetes. I think this is a way. When you run on Kubernetes pods, you have always variables like cube, hostname, cube, not port, cube. Here I don't have. So I'm not on Kubernetes. I'm in another place. But I started on Kubernetes. So here I'm on Kubernetes. Here I'm on another place. And I just pressed a button. Okay, then. Stop with the demos. Last thing is, skip this slide. We used all this stuff in a European project called Deep Health to build, as Dario said before, a Kubernetes-based deep learning training and inference platform to give practitioners the deep learning and deep inference as a service on medical data. And basically, we provided them with 2 different access paths. This figure is very complicated, but I will resume it very quickly. Advanced user access directly to kubectl and they can deploy pods and run their workflows as they want. Always authenticating with the key clock. So the resources are always segmented by the tenants. But data scientists or practitioners or practitioners with knowledge in Python that also do some machine learning stuff can access to Dossier, to their tenant, where they spawn a Jupyter notebook, and through Jupyter notebook, spawn a deep learning training, either directly on the cloud or on our Slurm managed HPC portion of the computing resources, which are bare metal with InfiniBand and with high-end V100 and recently A100 GPUs using these tools. So this was only to tell you that all the things we have told you today have been used in a 3 years European project. So at least in that case, were useful, basically.
Oh, don't be so modest. I'm sure that's a nice way of putting it, but I think it's really, really good to see that these things are being used directly in action. Sometimes we hear about technologies like, yeah, it sounds great, but can we actually see it being applied? And this making it into an academic environment where there are lots of different options, I think is a very, very promising sign.
Thank you. Yes, we wanted to basically, I'm not saying that from tomorrow you stop doing data science how you did since yesterday and start to do it like this. We simply wanted to explore like a different way to make different resources, heterogeneous resources, cooperate through the same interface, and to give access to people that are not IT experts to all this heterogeneous world. And this was basically the solution that came out. So with this, I can to small data. We run on a platform with 16 GPUs and 192 cores, with 5 different tenants and 8 datasets. So some tenants had multiple datasets, and also we hosted the winter school with over 50 attendees, always using this segregation stuff, so that attendees of the winter school had their own resources. They could not access the data and the computing resources of the production part, and they could experiment through Dossier and stuff like that. So also to teach people, because in this project they also developed a European deep learning and computer vision libraries. So this was a way to let the students experiment with those libraries. These are useful links, but you can see them, and I can conclude here. Thank you very much for letting us participate in that community.
Of course, absolute pleasure. And like I said, we're kind of new at this when it comes to bringing in these kind of use cases, seeing how these technologies are being leveraged on Kubernetes. Excellent demo, excellent explanations, getting the context, seeing where we've kind of come from, how this is being onboarded into the Kubernetes world, the advantages that are being provided, but also to see this being applied in this project. I really have to ask both of you that I would love to see a CFP about this for DoK Day and KubeCon. So I will be expecting to hear from you. In terms of other stuff, Dario, I believe you have a meetup today. Is that correct?
Yeah, absolutely. Yeah.
And so that's in how many minutes are we talking at this point?
It started 30 minutes ago.
Okay.
No, just joking. Yeah, it's a busy day, but people is waiting because there is the pizza, the beer. We're in Italy, so we are eating pizza all the time. So
and that's the thing. We have pizza and beer and other meetups, but I can only imagine the quality of pizza and beer in Italy. And
Iacoppo without pineapple.
Oh yeah, no.
Okay, no pineapple, right?
This could
because we have to leave right now if you are putting pineapple on pizza.
Okay, you heard it here first, folks. Godless Entropia does not respect pineapple on pizza. That is sacrilege. That is something not to be done. I will expect Iacoppo to be including a song in his next album specifically about that topic. But for real, this is a great conversation, and I was really glad that Iacoppo was able to join us earlier too in the Twitter space with Patrick, getting the great minds together to be thinking about the next steps for data on Kubernetes with these ML AI workloads. We'll be having Patrick's talk next week in San Francisco, and I'm definitely going to be incorporating some of the things we learned today in the Q&A when we're doing that. Gentlemen, thank you so much for your time today. Really appreciate having a chance to hear from both of you. Lots of exciting stuff going on. And like I said, I really hope we can get in a CFP from you for KubeCon. All right. We're good.
Thank you so much, Bart. Absolutely.
My pleasure. Iacoppo,
absolutely. Thank you.
Take care. Keep taking amazing pictures. Keep making amazing music. And we'll see you guys soon. All right.